All right, Cody here. Let's talk about this Mecanum wheel dealio. So the title of this is going to be "Let's Figure Out Mecanum Wheels." I say it as Mecanum wheel. I've heard it as like Mecum wheel or something like that. I don't think it's something that people really know the correct pronunciation of. So I'm going to go with just what I say naturally, and you guys can correct me if I'm wrong. But anyway, this is a Mecanum wheel. Whoop. Oops, I'm in select mode. There we go. This guy. And it is a really weird wheel, to be quite honest, and it's got some very interesting properties, which make it a little bit confusing to some people. A lot of people look at that and go, "Whoa!" Now, one thing that I don't like about Vex's Mecanum wheel is if we, and I'm nitpicking here, but if we look at this, if I can draw on this, there's like 1, 2, 3, 4, 5, 6, 7 sides. So like that's just really weird to me. There's no rule about how many sides you can build this with. I've seen them with many more rollers and many less and whatever. I had a friend in FRC who would actually make their own. They'd make their own rollers. They would cast them in this rubbery stuff that would make the roller, and they had a way that they would assemble the hub, and it was great. I apologize. I'm actually just coming off a cold, so my voice is probably kind of gone, but that's all right. Um, I just don't like 7 as a number. I feel like we get this really awkward shape, and I really don't like that the hub doesn't have like a proper like line of symmetry. And if it was 8-sided, it would. If it was 6-sided, it still would. 7 is really strange, but to the Vex guys that designed this, I happen to know that this was actually a bit of a challenge to do properly. These wheels are hard to build, and they were trying to make it pretty small and still work well. And when I was talking to them, I actually played a somewhat of a role in trying to get them to build this wheel. Um, it took longer, and the reason for that was that they wanted to build it right. That's exactly what they told me. So um, I'll give them credit. I'd rather see a wheel that works well than a wheel that just looks pretty. So I wouldn't be too put off by the 7 sides. Just know that that's kind of the number that probably worked best for them. So we've seen Omni wheels before. So the one thing that you have to know about Mecanum wheels is that if you look at them from the front on, like, oops, like this. Something to know is that these rollers do something very strange, which is that they kind of end up wrapping along in a way that, like, when you get right down to it, each roller kind of creates part of the circle shape. Kind of, I'm doing this badly, but you get the idea. So this wheel actually has a very round profile, even though it doesn't look like it does. Um, that's why this shape is so weird. Like from viewed from the side, it really is this continuous round thing. Viewed from the top, Mecanum wheels tend to look or tend to be drawn kind of like this. Like people just tend to like kind of like approximate the wheel by saying like, oh, there's like a roller here and one here, and that's kind of a really crude approximation of what's going on, but it kind of works. So we'll go with it, I guess. But it's really not what's going on, because if you look at how these rollers are shaped, they it's just not what's going on. Like it's not quite that simple. It's really like, this is going to be really hard to draw. I don't know if I can do this, but it's more like, you've got a roller which comes out like this. It's kind of pill shaped, and like you've got another roller which is a little bit off, and I don't know. These things overlap a little bit, so you tend to be. Yeah, I can't do that well. It tends to be such that if I were to draw a line through here, I'm gonna be on either two rollers or one roller at any given time, and that's just the kind of the way it is. So, um, but more importantly, the support is really going to be at one point of those rollers, or one of those rollers, and that point is going to continue this kind of roundness to it. So people think that it's going to be like bumpy, like bop, 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 bop. Not really. It's just it is pretty smooth, more or less. And the design, that's the goal, right? The goal is to have a wheel that rotates nice and round and smooth like a wheel. Okay, enough about the wheel. What do we do with these? Well, Mecanum wheels are sold in pairs of 4. So the idea is, if we have a robot, which I will draw better. I'm pretty sure I can draw squares and stuff. How do I do that? Another day. Okay, we have a robot base. The idea is that you put 4 of these Mecanum wheels on this base, like so, in a square. It should be relatively square-like. If you build it so it's more rectangular, like taller this way, it's like this. Whoops. You run into problems that have to do with turning radiuses, basically. It's the same story as a regular 4-wheeled robot. It's just not cool to be like a wiener dog kind of shape. It's just, you're not going to turn very easily. And that's pretty understandable, because we get wheels that are pretty far away from the center of rotation. So it'd be better to have like a square kind of shape. It's just in my opinion. And what people usually will show you is they'll usually draw the rollers so that they point out, like in an X shape. So like this, and like this, and like this. And they say that's the way you should build your Mecanum drive. And we'll do our typical circle thing. And point forward, that is. So they say like that's the way you build your Mecanum drive, and nobody really explains like why. What they tend to go into after this is just, here's how you program it. One of the fundamental things that I think people don't seem to realize is if we look very carefully, I'm going to draw this in red, at this top roller and this bottom roller, we notice something interesting, which is that there's an invert going on here. So viewed from the top, I should denote this, from top. From the top, it looks like an X, but if we remember that the top roller is going to be a 90 degrees off from the bottom roller, no matter, just if we're looking from the top, it's going to be one way, and if we look at the bottom, it's going to be 90 degrees the other way, just because that's how the wheel works. We realize that on the ground, whoops, not what I meant to do. Let me erase that. There we go. Perfect. Okay. What we realize is that if we think about this from the bottom, which I will now erase this and erase these, it's going to be the opposite. So the rollers are going to be kind of that 90 degrees out of phase on the bottom. And the reason I want to think about this from the bottom is because it's just going to make a lot more sense this way. So this is how the rollers are going to be. And again, am I doing this right? No, I did that wrong. My bad. Okay, so if we think about it this way, we have something that looks mildly familiar. Let me make the note this from the bottom. E-I-W. All right. That's an awful W. All right. So we have something a little bit familiar, namely something that kind of looks mildly like an X drive, in that if we were to draw our little blue arrows to be like slip, we have this weird combination where on all the corners we end up getting slip, and like we did before, in the diagonals we get push. Okay? So again, this is a drawing from the kind of view of what the ground is experiencing. So we can think about like we are the ground, and this is what would be what we would see if we were looking up, not if we were looking from the bottom. So you're still going to build this with, like, if you look down at it, it's still going to have that X pattern, the opposite of this. But if we consider what's going on, this is more like it. Okay? So if we think about this just for a moment here, and we erase the blue arrows, we only worry about the red arrows because that's all we're worried about right now, we should see some pretty clever combinations here. It should look kind of like an omnidrive. Like, for example, we know that if we want to go forward, we just do this. That's all there is to it. And so it turns out there's certain ways you can rotate these wheels to do just that. And for complicated reasons, the way you would actually drive these wheels is all forward. So you just power them all forward, and the robot goes forward. And life is good. And this is somewhat like what it's doing. So if we want to drive it backwards, the same logic applies. We just drive all the wheels back. And in fact, if we want to rotate, we rotate very much like a four-wheel drive would. We simply run these two wheels backwards and these two wheels forwards. And we get, in this case, this would be a rotation this way, which is what we would expect. Now, there's some very clever physics going on here, but there's also something else we can do, which is we can strafe, which I believe we run these two inwards and these two outwards. Whoops, I drew that wrong. Outwards. And the general notion of what you're going to get with this is an arrow this way, an arrow this way, an arrow this way, and an arrow this way. And if we think about it, it seems as if the arrows are following whichever kind of direction we're going, and they're just following the slants, right? Like this green slant just kind of projects outwards on that direction if we're going forward, and then the opposite if we're going backwards. And that's kind of what it does. So it's not so bad to visualize internally. Now, the physics behind it gets a little crazy, but we don't really need to understand all of that to understand what's going on here. We can kind of just stick with the simple premise of this is how it works. So, yeah, that's pretty much as far as I'd like to get into it. It's not a particularly deep subject. It's just this is what happens. So, sorry. The opposite applies. If we want to go left, we can just power the other two wheels inwards and the other ones outwards, and we're good. And, of course, we can do this to varying degrees. So we can kind of map these inputs to joystick controls, and we can drive it. So let's look at that. And so actually, what's interesting about that is in an omnidrive, if we were to have four wheels and we drove them and we want to do a right movement, it would be literally almost identical as far as movement goes. In fact, if you were to take, let's do this on another page. So I'll just erase this. If we were to take these two wheels here, and I'll draw their lines like this, and if we were to kind of bend those wheels such that they are straight and look at them, so we kind of just get them straight, what we realize is that we actually are driving these wheels this way and this way, and if we bend them, they get more like this, and if we bend them all the way, we realize that we're actually driving them exactly the way we are driving Mecanum wheels. And the same thing applies for the outside wheels. So if we were to take the outside wheels, and we know that we're driving them this way, and if we were to, whoops, that was awful. And if we were to bend these kind of, like this and this, we realize that we're driving these outwards and these ones inwards. So actually, for strafing, the code is almost the same. Actually, it is the same. So we already have the code for that. It's just the code for an X holonomic. Well, let's look at a different case. What if, what if we're going forward? So in a holonomic, if we're going forward, it's similar to if we're strafing. So we're going to go forward. So we have our four wheels. And as we know, it's this, and this. If we bend these inwards, if I think about what's going on here, like, just imagine I literally took the wheels and I just bent them, like, right across this line. These ones came in, these ones came in, these ones came in, just like we did before. And we realize that our vectors are literally going forward. I'll do this in blue, just because blue. I'm using blue to represent kind of like what you input, like what way you're driving the wheels. So we realize that we're actually driving these wheels all forward. They are reversed in various ways, but it actually turns out to be the exact same. And so what we're going to realize, what we should have already realized, is that the code to drive a Mecanum drive is literally the exact same as an X holonomic drive. It's the same kind of logic that you need. It is literally interchangeable. If you can take a code that will properly drive an X drive, and you take those motors off and you bend them 45 into this kind of pattern here, down the center of the robot, like I've described here, the code is proper and works great. So that's about it. There is some different drive properties. The Mecanum wheels drive on diagonals slower instead of faster. So they actually, they're whatever you put in over root 2 instead of times root 2. So that's good to know. So basically, we talked about the kind of spread of speeds of things before. We had talked about how holonomic drives tend to be faster on the straightaways, which are its diagonals, if you think about it, and then on the actual. So that's basically describing the same thing that we did before. It's just the numbers are mildly different. Instead of we're going root 2 in this direction and 1 in this direction, like a holo, X holo. Mecanum tends to go, I believe it's 1 in this direction, and then 1 over root 2 in this direction, if I've got my math right. And that should be a 45. I did that wrong. So that's kind of important to know. Just different characteristics of the wheels. Another neat thing about Mecanums, another reason people like them, which I probably should have brought this up earlier, but it's the fact that you can simply mount things straight up. Like you can kind of, it's an easier build. You don't have to deal with 45s. You can just make a four-wheel drive, basically. And the neat things about Mecanum wheels is if you have 4 motors on a chassis, you can take 4 regular wheels with their motors, and you can literally swap in Mecanum wheels, and you have an omnidirectional drivetrain. So, you know, that's pretty cool, actually. You can take any square drivetrain that's got, as long as these motors are mounted like as a square, which isn't a great example, but or near a square, it should be around there, then you should be able to put Mecanum wheels on there and not have any problems, as long as from the top, you get an X shape out of the wheels. So you should be like this. And remember that on the bottom, it's going to be reversed. So it's going to be on the bottom, it's going to be like this, which is more like what we're used to. And that's the rollers. So it's, you know, these rollers are going to be like this. Okay. So bottom. This in green is the bottom view, ish. So that's essentially the way that works. Okay. And my eraser is being stupid again. There we go. It's this pen. It doesn't like to. You have to tap it really fast to get like a valid click out of it. A little faster than I'd like to, but that's okay. I don't mean to complain. So let's kind of recap really quick. Vex Mecanum wheel has 7 sides. Don't worry about it. The Mecanum wheel ends up making a round profile from the side, which means it actually rolls pretty nicely. That's intentional. The rollers kind of invert from the top to the bottom, or they don't really invert. They just go from like one way to 90 degrees over. So you can kind of see that in this picture here on the side here, because we can see that there's a roller like this on top, and on bottom there's a roller that's kind of the opposite. I'm drawing that badly, but you get the idea. So we can see that there's kind of an inversion of the rollers between which side you're looking at. So frame of reference is a little bit important when we think about these wheels. We know that that these wheels work approximately like an X-Hollow, kind of, in the sense that they have, it's actually a little bit different, the directions that are involved here, but the way that you operate these wheels ends up being essentially identical, because the power, and the reason for this is because the power ends up rolling like this, which, if you think about it, this kind of picture looks very similar to an X-Hollow, right? An X-Hollow has blue arrows and red arrows in exactly the same places, even though the rollers, which in this picture actually are the same kind of rollers that you would experience on an X-Hollow, right? Like from the bottom view, these rollers are pointed in the right direction, but on the top it's going to look like they're pointed in the wrong direction. That's why, that is because of that inversion we talked about, right? Because on the bottom we're going to get this guy, but from the top we see the black one, or I'll write that in blue. The rollers are going to look like this. So don't be confused by that. That's the way it should work. That's normal, okay? Since this picture is essentially the same as an X-Hollow, the same code that drives an X-Hollow works, and that makes sense, right? Because if we're doing essentially the same thing, the same code to drive it should work, and it does. What's more important is just to understand that the advantages and the disadvantages. So the advantages are mostly in that this drive can be slightly easier to build because of the squareness of it. Again, you don't have to deal with 45s, which is great for a lot of things, which is why we actually see this in industry. Well, I kind of screwed up the wheel placement there, but you get the idea. This is why we tend to see these in industry more than we see holonomic drives, because it's actually a lot easier to build something that's square than something that has these weird diagonals. A lot of robotics people like them because it's really easy to build a square chassis, and they want the advantage of strafing. And what they like about the Mecanums is that they turn just as well as a four-wheel drive. They push extremely well as well forward and whatnot. And they go basically as fast, and they only lose some speed when they're going in the diagonals, which tends to not be that big of a deal. Now, in general, I'm not a huge fan of the Mecanums because the wheels are very complex, and they're big, and they're heavy. That's one complaint. The second complaint is there are a lot of moving parts. Technically, there's about as many moving parts as an Omni drive, like a regular holonomic drive, but it's just these wheels tend to be a little larger, and there tend to be less points of contact, kind of. Not really, but I don't know. In my mind, I just see it as like, unfortunately, the weight of the robot is going to be like on one side of the wheel, and then on the other side of the wheel, and then on the other side of the wheel, like often, because of the way those rollers work. The other thing that kind of bugs me is that people who use these robots that drive them tend to treat them a lot more like a robot that tend to treat them a lot more like a robot that is a four-wheel drive robot but just can strafe, more so than like a robot that can actually move in any direction. So they tend to drive these things like a big tank, like a tank, you know? Like, yeah. And in fact, what a lot of people will do is they'll actually not program it the way we talked about, but they'll program it like a regular tanked robot would, so where they have like one side of the wheels on one stick and one side on the other stick, and maybe like some strafe mode or something where they can kind of do it. And that for me just kind of defeats the purpose, right? Like I want one joystick to be the direction I'm going and one to be the rotation, and I'm good with that. That's the way I like it to be. But if that's what you want to do, that's your prerogative. That's fine. It's a design choice. So there aren't really too many trade-offs or disadvantages between Mecanums and holonomic drives or a four-wheel drive. You gain a little bit. You don't really but compared to a four-wheel drive to a Mecanum drive, you really aside from the traction hit you take from having less rubber on the field, touching the field, that is. Aside from that, you can pretty much drive as well as you could, but now you can strafe, which is cool. The design disadvantage is just that you have to deal with this big wheel, which is relatively easy to overcome. I mean, you just find a space for it, and you're done. It's not so bad. And yeah, so it's just a really, really cool wheel, and we should. I don't know who the hell thought of this stuff, but it's really an impressive thing. So it's just cool to think about, and to see kind of physics applied this way, or at least motion applied this way, is really unintuitive to at least to me it was. So I just think it's a really cool concept, something worth sharing, and so that's kind of the point behind this video. And of course, holonomic drivetrains just freaking rule. So why not talk about them? Alright, if you guys like this video, let me know. Subscribe, do all that likey stuff. Honestly, I don't really care, but it helps me know that you guys actually care about these. And whenever I look at videos that have lots of views and likes and posts that people talk about, I'm like, oh, I feel a little happy inside. And I'm slightly more inclined to do more, which is probably good for you guys. So anyway, I'm going to go finish some homework, and you guys have a great night.